October the 31st, 2021. Guys, you're looking at this morning's spaceweather.com. It's one of the links on our website. Solar wind in the left is elevated by about 100 kilometers per second at 421. Proton density still a little dense at 13. But let's see what they're saying about the information. It says weak CME impact. A CME hit Earth's magnetic field on October the 31st at approximately 10 o'clock UT. It was just a little later than that, according to some of the instruments. The impact was weak, a far cry from the big hit we expected. What happened? It's possible that the bulk of the October 28th CME missed our planet. The reason is they're saying it was directed somewhat south of the Sun-Earth line. But guys, there were instruments picking up protons and electrons coming in as early as the 29th through the 30th, and we were seeing ground currents expand, things like that. We did not get that large impact, which is a good thing. Now, what else did we talk about that could occur? Increased volcanic activity, and we're going to look at some images today from La Palma, and it looks exactly like that's what's happening. It looks like it created more lava flow, but it says this, despite the feebleness of the impact, minor G1 class geomagnetic storms are still possible in the hours ahead. And then what you're looking at is last night, Christopher Matthews was recording these auroras over Iceland. It's on the south coast of Iceland. He was waiting for the CME to arrive when this suddenly filled the sky with auroras. Now, we had two CMEs, and there was a CME that left on the 26th, so they're not really sure exactly what he was catching there, but that was the time when we were getting the energy from the CME. It says now the solar minimum has passed. The sun is waking up again. Solar magnetic fields are strengthening, providing a stiffer barrier to cosmic rays trying to enter the solar system. And we'll talk about that more, but they're talking about the sun also has a shield, guys, the heliosphere, and it radiates out through the solar system and protects the solar system. But when the sun is weak, more space radiation penetrates all the way to the core of our planet. Again, you're dealing there with the heliosphere, the sun shields. But it says, who cares about cosmic rays? They're down-to-earth form of space weather. They can seed clouds, trigger lightning, penetrate commercial airlines. According to a study from the Harvard T.H. Chan School of Public Health, crews of aircraft have higher rates of cancer than the general population. The researchers listed cosmic rays, this is important, irregular sleep habits, and chemical contaminants as leading risk factors. Somewhat more controversial studies, and they're listed here, and there's 4 that are linked. They link cosmic rays with cardiac arrhythmias and sudden cardiac death. Important. Now, let's look at our shields during the event overnight. It's very interesting because CERN cranked up. We're going to look at their charts and how they powered up during this period. Now, watch as our shields start to distort. And I'm going to go to the CERN's instrument panels, and we'll take a look at that. But as it goes through this section, you're starting to see some bending that's very unnatural. The rounded shields are not functioning properly. Remember, CERN's shields, or their magnetic field, is 100,000 times more powerful than Earth's. And check that out, guys. That's very abnormal. I told you in a video before and over the last several years how this distortion occurs. And this is leading up before the impact of the CMEs. There were 2. Now, again, they weren't as strong, or they slid under the Earth somewhat, but CERN took full advantage of it, and it just goes to show and they're doing it by Tesla technology, not Musk, not that Tesla, but Nikola Tesla. Check this out as it goes through the day here. We're looking at it, 708, 717. Those the impacts are already affecting our planet at this point. But notice that the shields are still standing out. At the bottom, you've got a series of numbers starting with 0 in the middle, 5, 10, 15 to the right. 12 is about the average standoff point for our shields in this. The Earth is in the center. The white circle is indicated, half of it's white, guys, and that's the sun-facing side, and the energy of the sun's coming from the right. But as it goes through the day, you're going to see it pushing further and further away from that 12 standoff point. Now we're down into 8 and 9. That's the pressure that was building. Guys, there were ground currents going off, things like that all around the planet. And the electron and proton charts from the satellites were picking up energy rapidly increasing up starting on the 29th. And we'll look at another magnetopause model. This one's backs off a little bit. Again, the sun is to the right. The energy's moving from right to left in the screen. The Earth is in the center. Notice that red line that's bulging out in front of the black dot, which represents the Earth and its orbit of the satellites. It's not letting that red radiation, that high gamma energy into the Earth. But there are cracks in the shields, and they're called cusp, C-U-S-P. And the shields are set up to block the Earth from this type of radiation, but it doesn't always work. Again, as we go through this, you're going to see the effects. You can see the energy waves coming from the right of the screen right there, orange, and they'll get darker and larger as it goes through the day. Right now, our shields are doing a good job. They're not letting much radiation in, but right there, guys, you'll start to see it change. Right here, now the cusp have been opened enough to let the radiation into the planet, and you'll start seeing inside the red lines there. That's kind of our magnetopause and magnetosphere, the penetration. Here again, look at the energy penetrating into the planet and into the inner shields of our planet. Just check that out. Now, the magnetopause is a unique study in itself. It actually senses the energy coming and will expand itself out. But right here, it got caught off guard. The rear and front sections, and here it's even worse. Look at the radiation penetrating. Look inside the red lines, both front and back. As we go through the day, that's 5:40 UT time. Continues. We're being pounded by radiation. What does that mean? That this is what's going to affect the volcanoes right here, because this is being transferred. See all those lines that dip into the top in the south of the black dot that represents our planet? Those are heating the core during this period. Now look at that, guys. See that large red wave coming in at 10:45? That's why I'm saying they said about 10 UT. It was about 10:45, and the satellites were starting to feel it, and the Earth was starting to get impacted with the heavier energy particles going through the day. And right there, you're pretty good. Notice the blue out in front of the planet. That's part of our magnetopause. But that can be stripped away by this high energy. But right here, as the energy is stripping that back, it's also feeding energy back into our shields, into our magnetopause, and it expands back out to try to protect our planet. CERN is running beam 1 on the left in the blue. The beam 2 is down right now. Both were up during these events, and I'll show you that. They took full advantage of the ground currents, and the currents that come through our magnetic lines of force. Here, the red and blue beams were very hot. Check this out. Notice your timestamp at the bottom. Right here, as the thing was coming in, the beams were shut down, but there's a black M shape there. That's the main power. They add the power of the blue and red beams. They get the black beam, and right at just before 1300 hours, they were peaking their main power. Here you can see that beam 2 is down. Beam 1 is still running. But again, everything was hot when it needed to be. How does it happen? We're going to get into that. But notice this is live. You can see the clock ticking at the top. They're colliding two beams in a 17-mile underground collider. It's huge machinery. It's almost mind-boggling to know what they have there. But again, here, going back to the shields, that M at 1300, guys, represents the peak of the power that hit the satellites around 10:45 UTC. Here, this is awake, and it's a new section that they started using last year of the entire CERN facility. They can use smaller systems that will strip protons back and increase the speed of these events, and that's what you're looking at in the two sections in the bottom. Now, this is outside CERN's entrance gate, and what you're looking at is a Tesla tower. There's steps inside there, wind through there, goes through some of the offices, and then all the heavy equipment is underground. Where did they get that idea? It came from Nikola Tesla. It is used to not only transmit in Nikola Tesla's mine, but also to receive energy. This is part of the Atlas machine, just a section of it. Look at the size. You can see some of these walkways, gang plates there. But guys, that is huge. This is just, again, one section. When all that starts rotating, high energy. Here's a picture of Nikola Tesla's giant tower to send wireless electricity around the world. Notice the top of that tower. It's the top of CERN is designed exactly like that. It's receiving, and possibly it could transmit. Now let's look at some incredible drone images today over La Palma. And we have a lot less ash in the air than we did the last few days there, and you can see some very clear pictures. Very hot lava. This is coming out the side of the mountain and dropping back down into a lava tube. But as this drone flies up the mountain, it's going to show you some amazing images. Check how hot it is. It's getting later in the afternoon, but everything is very liquid, and I think we're seeing the results of that as you get further up this mountain. You get a look at something we haven't seen much of, and that's this section of the mountain here that's created. It kind of caved in on itself. It looks like one of the other vents, but most of those have been further up that mountain. Now, that caldera right there is very interesting, guys, because we just haven't seen that much of it. Check that out. Again, the vents that we've seen have been much further up, but this looks like a little newer one. Here, coming out of over that vent, we can see that there's nothing pouring out of the top. Those vents there are dry, but it's dropping down and going through lava cones and caves and coming out down below. There's places, guys, where the lava is 40 meters or 120-something feet deep. That's a 12-story building. Now look at this, again, National Institute of Spain. Check this out. As we get up towards the main vents. Very hot. You can see on both sides you've got very hot lava, but this center is white hot. Highly visible even in the daylight. Moving up the mountain towards the main vents. Still a lot of energy, still a lot of gas coming out of that. And look out how full the top vent is and how it is overflowing. Again, different drone images. Check this out. That cone is getting bigger and bigger and taller. A week ago it was over 600 feet, so it's probably close to 1,000 now. But looking back down towards the cities, very hot, a lot of it. And I think what we're seeing is the result of this incoming solar energy. Again, the protons and protons, electron, high energy charts have been rising since the 29th. So this has had time to go through that. But I just wanted to kind of give you an update, guys, on what's going on. Let's pay attention. Tonight will be a very interesting night for the volcano there. It's a heads up. Be safe.